Hi everybody, Andy from Audio Keller back again with another video. This time I have another amplifier from the American Warriors model range made by Hifonics, but this time I have the 4-channel version. This video is also user supported and a nice subscriber sent this nice little amplifier to me, and it was also a manual included and a warranty card in very good condition. The manufacturer's ratings are 35 watts by 4 into a form load of continuous power measured at 12 volts, 45 watts into a form load at 14.4 volts. Here you can connect your speakers, your battery plus, your ground terminal. Here you have the gain parts for the fronts and for the rears. The input sensitivity is 0.1 volts to 2.4 volts. And let's see what this nice little amplifier can do. The Hifonics Eagle is a 4-channel amplifier, so I connected 4 power resistors. That means we have 4 ohms per resistor. I'm starting with continuous power test with a 1 kHz signal. No clipping. There is clipping. I go back. That's okay. And I have a peak voltage of 39.2 volts. With 39.2 volts, the amplifier puts out 49.2 watts of continuous power into a form load, all 4 channels driven into full power. Now let's have a look at the amplifier's efficiency. Here is a closer view of the clamp meter. 22.3 amps. I calculated an efficiency of 64.4%. The next continuous power test, but this time with a 50 Hz input signal. .2 volts. With 50 Hz, the amplifier delivers 44.3 watts. Testing for dynamic power with 1 kHz and 20 cycles. So we got all cycles at the same voltage level. Checking for the first cycles. That looks okay. We have around 40 volts. Yes, that's true, 40 volts. I go to the last cycle to check if the value is almost the same. It's a little bit lower, it's 39.6 volts. The first cycles were a little bit higher, so we have 51.3 watts into all 4 channels into a form load of dynamic power. And at the lowest cycle I have 50.2 watts, 8 cycles. And I have a little higher voltage, 41.2 volts, and I guess a little lower at the last cycle. .4 volts. With a burst of 8 cycles, we have on the lowest cycle 52.3 watts and on the highest cycle 54.4 watts into a form load, all 4 channels driven into full power. And the next test is just 1 cycle, that means peak power for 1 millisecond. And here we go, we have a higher peak voltage. It's 44.4 volts. The amplifier puts out 63.2 watts into a form load, all 4 channels driven into full power. And now only 2 resistors are connected to the amplifier. That means I have a 4 ohm mono load connected bridged mono to the fronts and also a 4 ohm mono load connected bridged mono to the rears. That means I'm testing 2 ohms per channel, all 4 channels driven into full power. After the first test of dynoing with 1 kHz continuous, it popped my fuse, so the amplifier's manufacturer recommended a 20 amp fuse. This is what it is here. I'm sure the amplifier is able to handle continuous power 2 ohms. In this case I'm not going to install a 30 or 40 amp fuse because this is not my amplifier. If it were mine, I would do it. So I'm just testing for dynamic power, and I'm going to replace a fuse. So in this case, I can say we don't have all cycles at the same voltage level. I jump directly to the last cycle and check it out. And we have 32.8 volts at the last cycle. And 34. At the lowest cycle I got around 68.9 watts, and on the highest cycle I got around 74.1 watts. Now I'm doing the 8th cycle test. The higher cycles at the beginning have a peak voltage of 36.4 volts. Now I go to the lower cycles. 32.8 volts. At the lowest cycle we get 68.9 watts, and on the highest cycle we have 84.9 watts. I'm going to check the peak power with just 1 millisecond. Clipping here, but we take the peak voltage and we have 38.4 volts. We have 94.5 watts. And now it's time for the sound check. You can easily support my work just by leaving a thumb up or subscribe to my channel, leave a comment. See you next time, and thank you very much for watching. Bye bye.